Hi, Professor. This is Dan Riseman with assignment 1.6. For question number 1, describing the line in words that x plus y is equal to 1 and z is equal to 4 is going to form, well, I have the diagram right here. Right here, basically, I have y is equal to negative x plus 1, and I have z is equal to 4. Two planes intersecting. You can see they're going to form that line. Now that line, what it really is the line is a set of all points where x plus y is equal to 1 that lie in the plane z is equal to 4. Now on top of that, I did a line with vector format right there, as you can see, and I send that to you in my notes as well. And it's quite interesting, that intersection. For question number 7, you have this plane, and I'm trying to find the slope in the direction where x both increases by 2 and y increases by 3. Now, taking this away and putting this down where you have the value of 0, 0, 5, 0, 3, 11, and you have a 2, 0, 7 in the back, doing that, what I proved with my notes is that when x increases by 2, z increases by 2. When y increases by 3, z increases by 6. Therefore, if x increases by 2 and y increases by 3, z increases by 8. Now, I used a little bit of Pythagorean theorem, which is always one of my favorite things to do, to show the delta x and the delta y, and the eventual slope is going to be 8 over radical 13. I give the approximate answer there as well. But the exact answer would be 8 over radical 13. For question 8, it asks us the plane, which is very similar to what we had, and we're going to determine point B. Now again, point A is going to be at 0, 0, 5, which would be back here. We have a point in the back would be 0, 3, 11, and 2, 0, 7. And what we're going to do here is, again, rise over run, which is our definition of slope. And by doing that, we see that there's a couple things that are going on there. Really, with delta z, we have it changing once with a 2 and then changing once with a 6. I detail all my work right here for you, Professor. And what happens is you take the point 0, 0, 5 and you add the 2 with the x, the 3 with the y, and the z actually has it changes twice really, with a change of 2 and a change of 6, and the resulting coordinate for B is going to be 2, 3, 13. For question 13, the notion of this derivative, and it's a very good question. The derivative function at a point is related algebraically. Well, if algebraically, the key thing here is I want to prove what's going on with a change in y over change in x. The key of derivative is this, though. It's a notion that it's the slope at one point, which would be the derivative. The key on this is that x sub 1 and x sub 0, as they get really close to each other, they would become the same point, and my formula would show that that would actually be the slope at one point, which is the derivative. And for part B, here, geometrically, I graphed it. You can see my points. And here, as x, the delta x approaches 0, the 2 points in the line they go through would actually become 1 point. And what is the derivative? It is the slope at that 1 point of the line at that 1 point, which is the derivative, and I detail it here for you. Thank you, Professor, and hope to speak with you soon.